Hey folks, hi. Welcome to this talk on batching, suspense, and server components, which are new and shiny features that came along with React 18. And I do feel like the community also feels like this is a cornerstone for the React, India history of React, where these three features is going to forever change how you're writing your client-side application and how you think about your SPAs and everything all together. So let's get deep dive into it and see what these features are allowing us to do. A little bit about me. I'm Sendil. You can reach out to me at this handle in Twitter or in GitHub. If you feel free to post any questions or doubts that you have on this, I'm happy to go and talk about it. So what we're going to see today, we're first going to see about batching. In the batching, we're going to talk what, why, and how, and also like few considerations that you have to take into account when you're doing a React component and how to eliminate batching or how to add in batching if that is what is required. The next is introducing the new concept of suspense and server-side rendering. What is that? Why do you need it? And how we can use that or how it works. And few issues or few things that you have to know when you're using suspense and SSR. And finally, the server components, which is a beta feature yet, but this promises to be one of the best things that we can do at this point of time, which gives a very good performance and also has a very good changes the way in which you're going to build your application completely. I think I'm really excited for server components and the promise it is giving. So let's start with batching. Batching is nothing but you group multiple state changes or the prop changes or state changes exactly in React together and then do it on a single re-render for a better performance. Like instead of doing multiple re-renders, you combine all those things together. If you have subsequent state changes in your application or in your component, you batch them together to build that staging or batching feature that gives you like instant performance. And it basically gives you a better performance. It avoids you having an unnecessary re-renders here and there. That is one of the major things that it kind of eliminates. And it also provides you a consistent user experience. For example, if you remove having like infrequent state updates and batch them together as a single update, now your component has to re-render only once instead of it re-rendered multiple times, which makes sure your application is consistent. And it also avoids having an intermediate state in your application. So how is it going to be beneficial? If you're asking that, then this video is a perfect example. So for example, if you're building a component and this layout shift slightly happens when you're actually working on it, when it's actually loading and things like that, it is very difficult for folks to understand what is happening. For your user to create an inconsistent experience, for you, it is very subtle and it's very hard to figure out this bug once you roll it out if you have a bigger application. In technical terms, we call it as a layout shift. Batching would help you to avoid it. It will not completely eliminate it. You still have to be aware of like there are most scenarios where in which layout shift happens outside of the context of batching. But the thing that you don't know, unintended things that happen because of batching is not happening previously, would be avoided by this feature. So batching, how it works. In React 17, if you take a look, the simple component, this is a clicker component, which is an on-click handler. On click of it, it increases the state count and sets a flag, toggles a flag. Based on the state of the flag, it shows color, changes the color of that particular element. Now, what happens is like when you do this, the batching actually happens here, which batching here senses like re-rendering actually happens here. So it calls the on-click, it sets a count, it sets a flag, and then does couple these two together as a single transaction, and finally does the re-rendering for you. This is good. This is the perfect way of doing batching. But the problem comes out when you introduce an async context here. So in the async context here, the same component, but I'm having a fetch something over there, which is just a method call, but this is an asynchronous method. And on successful resolving of that promise, I'm going to call set count and set flag. These are two state changes. The problem here is until React 17, the re-rendering happens at each and every state change. So set count, re-rendering happens. After it sets count, the re-rendering finishes, the set flag goes in, and again a re-rendering happens. Now the same component that you've built is going to re-render twice for every change on the state, which is annoying, right? Because too many re-rendering, it decreases the performance. Too many re-rendering gives an inconsistent user experience. In React 18, they kind of like made the compiler, or they made the runtime compiler to be very, not the compiler, runtime execution ignition, is a very more efficient, that it even detects the state changes that happens inside the asynchronous context and has the ability to couple them as a single batch and then does the re-render at one side. So for example, the same code inside the asynchronous context, the re-rendering happens only once. This eliminates the possibility of having multiple re-renders inside an asynchronous context too. But wait, there might be a scenario because components are really weird and you can set your imagination for doing whatever that is required out there. So you might need re-rendering at some places where you have to force the re-rendering to happen. Previously, we used to use asynchronous context to do that, which is the counter example of what we have seen so far. But in this scenario, what you can do is like the React DOM introduces a new API called flush sync that's inside the React DOM as usual. So you can flush sync that particular state change, which basically means you're telling the compiler or the React DOM to flush the changes in the state into the component synchronously. So which basically means the re-rendering happens here and the re-rendering happens here. Thus, it provides a way for you to manually select the option that you want. If you want the re-rendering to happen, use this thing. But React always does the batching for you, which kind of normalizes everything happens and makes it easier for us to give a consistent user experience. What are the few things that you have to take into consideration about batching? The user-initiated events like key press or a click, React actually ensures that they are properly handled and processed before the next event. So you kind of eliminate the worry about having two submissions of the same form, which is a frequent issue that you're going to have. You're going to press 2 clicks on the submit button. Sometimes the form gets saved twice. And it kind of like removes that problem away, and which React does all by itself, so you need not worry about it. So basically what it says is like it will process the first event and then only process the second event. It will not do batching of those two events. And React also like sits and thinks about like when it is safer to do, conceptually if you think about. There are some scenarios still where batching will not happen. When React couldn't determine how to do the batching together, it will just eliminate the having of batching over there, which is a safer option. So you're not completely out of batching not happening inside the asynchronous context. There are still some scenarios in which batching will not happen, and you need to be careful with that. So that is a few gotchas that you have to know when you're using batching. So the next area is suspense in SSR. As you all know, SSR is server-side rendering, and how suspense helps in SSR, so server-side rendering. So what is suspense, first of all? Suspense is, it lets you sit and wait for the code to load and specify the load state. So for example, I have a component, I know it's going to take a few seconds to load because the data is so complicated and the database I'm using is legacy, so it's going to take a longer time. That's just an example. But if it's going to take a longer time, then I can wrap this complete module inside suspense and say like, hey, wait for the code to load. And until it is loading, show the state. This is show this value to the component, your loader. So you show the loader until the data is getting fetched. Once the data is fetched, replace the loader with the new state of component, which is perfect, right? Like we do have a lot of components in the while where it gets an API and then it shows that beautiful data to the users, and we want to make sure we are giving an impactful experience for the user. And suspense really helps you over there. But on the other hand, SSR is server-side rendering that generates the HTML straight away from the React component in the server itself. So in the server, the React will run on it and then extract the HTML values and then pass those HTML values to the DOM. The DOM re-renders it with the help of React on the client side. So for example, this is the overall picture that you're going to see, a page with a header at the top, a sidebar, a hero image or some central component, and then a smaller component over there. So this is the final state that you want to render for your application. In that scenario, when the first loading happens, the loading is starting, your browser starts to work, it sends out the request, 3 in parallel or 6 in parallel, and then it downloads all the resources and then starts showing the content for you. But on the server, it fetches the data, it renders the HTML, because we are talking about server-side rendering, it renders the HTML from the fetch data and the React component that you've designed. It combines these two and executes them and then creates an HTML for you. And once HTML is created, this HTML is thrown into the browser. Now the browser renders that HTML. The whole advantage of having something like React is basically to have that interactivity, right? That interactivity which gives, like, you can take a particular piece of a location in your browser and make it more interactive and things like that. That is there. But plain HTML does not provide you that level of interactiveness. So the component that you're going to see is not interactive. They are basically the HTML updates only, and it doesn't have any function there. You cannot go ahead and do kind of crazy animations and all those things because the interactions are not possible yet. So user just states a static page over there. And then the React, what it does is it goes and hydrates the component, hydrates those values such that interactivity is given into it. So what happens here is like, it first finishes the fetch, which is basically bring down all the things that is required for it to run. Once the fetch is done, it finishes the loading. So it basically loads the page in HTML format, which is a static page. And then it hydrates. So again, that hydrate has to be finished before it can go to the next stage. So that hydration has happened. So hydration is basically like you're pouring water on your components that are static. So it makes the component more dynamic. And finally, it lets you to do interactions. And this is how it works in React 17 SSR, which basically has like 3 stop states, and it has to happen once those stop states is finished. It will wait for the next state to complete. Then it goes for the final stage. And only when it is at interact, it can go ahead and interact. So in React 17, you have this render to string function, which kind of renders everything to string. But from React 18, instead of you focusing on just building the HTML string and then using it, we have a new function called render to pipeline, pipeable stream. And what it does is like it streams the HTML into the browser. So which basically means like the HTML can be processed on the fly and it can send to the browser as a streamable component rather than having a one entire chunk of string, which happens on React 17. So that's where Suspense comes into picture. And when you put when you go back and see that the layout that we have a header, we have a footer, and then main. I'm just remove the sidebar for now. But on the main, we have post and comments as 2 components. The post lists down the post, and the comments list down the comments, a standard block kind of architecture where you have the post, which is static content, and the comments, which can be dynamic based on the interactions that are happening. So if you're rendering both post and comments as server-side rendered here, then you can wrap this comment inside the Suspense tag itself, which basically means this dynamically rendering comments is now you can have a beautiful loader over there, and you can wait for the data to come from backend and show it to the users. So that is what you can achieve with it. Now you can suspend the load of the entire comments, and you can wait for the entire data to be loaded. Once it is loaded, you can fetch the data and show it there. So what is exciting here, this is normal thing. It's basically like you cannot do this Suspense on comments if the comments is server-side rendered before. Now you can do it because the component is server-side rendered, but because of the render to pipeline pipeable stream, it is possible for us to render this comments as a stream instead of having a string that is going to wait for the entire thing to complete. So which is great advantage for us. So why it's exciting? Because You can load the page before all the code in the page is loaded. Since you have a stream that is coming from there, as soon as you receive the stream, a particular end of stream, you need not wait for completion of the stream. You can actually render those components and show it to users and load the pages. So you need not wait for the entire stage to complete. You can hydrate the page even before the HTML is completed the stream. So for example, if your HTML, like you have rendered a part of your HTML into the browser itself, now you need not wait for like entire HTML to be rendered in order to hydrate. You can start hydrating the portion which are visible, which makes it even more exciting. And you can, once you hydrated the page, which basically means that you can have the interactions on those pages without you have to wait for the completion of the streaming, completion of the hydration, and completion of whatever that is in that page. Basically, you're just focusing on that one particular comment section and then building it. If you put it in an example, like you have 10 comments, with Suspense in SSR, you can load 5 comments or 3 comments together, or one comment by one comment. You can load them because the partial streaming compilation that is available. So you can compile it, send a particular stream, and use that stream to load the first component. Now you can render the like button and reply button for that particular comment using hydration. And you can make them interactive because hydration is completed. Now we can also do that the same thing for second comment, third comment, and progressively going on. But the interaction you can enable at every button levels, which is good. And a few things that you have to know is like hydration happens inside or within the context of Suspense itself. It will not happen outside of the Suspense context. So in our example, you cannot do that hydration for some other server-side component. For example, the post, which is also a server-side component, you cannot do it. It has to happen inside the Suspense context itself. And it's always parent first order, which is what basically React does across the board. It's always parent first order. And React holds off from dispatching event until entire parent tree is done. So it also knows like if you have a single parent and everything that inside the parent is loaded, then only you can actually do the interactions in that. Or you can do an interaction, for example, if the entire comment is loaded, then you can click on the like button, which shows up what is required, which shows up like the like symbol and everything, increases the count of it. But if that parent tree is not completely loaded, for example, if the streaming for that particular parent tree is not complete, then React will not dispatch those events. It will hold off until the hydration is complete, until the parent tree is completely rendered. And it's also an opt-in component. It cannot be an opt-out component. That's what server-side rendering Suspense is all about, and that's where it helps. And the next part and the final part of the presentation is server components. Server components is definitely a turn point in how you're going to design the application. It's still in a beta feature, but it will enable you to rethink about whether you want to go for server-side or a normal component. So what are they? Server-side components are nothing but a normal React component. There is no difference. They are just a React component. But the difference is they will run on the server, and which basically means like similar to server-side rendering, there is no relation between them. So similar to server-side rendering, they all run on the server side. But the difference is they are actual React components. They are not rendered into HTML or something like that, but they are actual React components. So it's not in production ready. The work is still going on. On the other hand, it's an exciting feature, and that is the reason why I wanted to talk about it today. And how it works. So here you have three, like the naming structure of a file is going to be differentiated. So you have a server.js, you have a client.js, and normal JavaScript files. So the difference is like whatever you write inside server.js will render on the server side of the world. And whatever you write as a .client.js as an extension, it will render on the client side, which is on the browser. And there is this nominal bunch of JavaScript files, which you can use it both on server.js and also client.js, which is basically a common file that can be shared across. a minutal file can be something that is required over there. So the server-side components runs only on the server. It will not run outside of the server. It runs only on the server. So let's consider that you have a server here, and you have a server-side component, which is that React symbol over there, and you have a database, file system, and APIs. So with server-side components, you can directly access them from your server to the database or the file system or the APIs. You can do the access, build the component, and once you build the component, you can send it to the client. That's how it works. And I think it's much more faster for servers to connect with database or file system or APIs, because usually they live under the same virtual private network and they have the connectivity that is much more sorted, and it's much more easier and faster to interact between these two. If you're putting that on the client side, the main problem is you have to work with the network latency. You have all the problems of inconsistencies that is given by the network and the unreliability of the network. You're kind of eliminating that and safeguarding everything inside. So you're not exposing any of the connections to the outside world. Everything is rendered. You get this component as a server component and use that server component to the client side of the things. So how it works? So it basically makes sure the dependencies and libraries that you're adding are free. Talking with the database is free. You don't need to worry about any extra library that you're going to add. So when you're server rendering this NPR component tree structure, for example, I have this block category, and it has it goes through all the posts in MyDB, and then for each post it's going to create a header, span, and an article, which was basically a markdown conversion. So I used a marked library here that converts that HTML into that converts the markdown content into HTML and puts it inside the article component. And then I have this date library, which is very costly. I've just named it as costly date lib. And this library is very costly, and it has a very good higher, let me talk about the kilobytes in the next slide, but it has this date, which converts the date into some readable format. And this is the HTML that is going to the client. So here you will not have any interactiveness inside the application. So you cannot use useState inside the server component. You cannot have user events because you have to conceptualize them as something that happens on the server, where you cannot do any event transition or user event capturing over there. So that is not there. But the other thing that you can do is you can import a client.js, and you can also send in props. These are static components or static things that you can use inside the server components. So server components are flexible in a way in which you can import a client.js and put all the interactiveness in the client.js, so it renders only on the client side. And you can also send in props between these components, which makes it even more interesting. So there are few libraries that are already available, like React Fetch, React FS, and React PG. They are basically React Fetch for fetching inside the server component itself, a file system for accessing the file system, PG is for accessing Postgres database and everything related to that. One thing to add here is since I was talking about this dependencies over here, all the dependencies that you're going to see here has a cost attached to it, right? So the marked has, for example, let's have marked is around 500 KB, and then costly date library, since I mentioned, it is going to be 750 KB. And database might be a very simple file that it goes and accesses, so let's not worry too much about the kilobytes over there. But when you have the server rendering of this, when you put it inside the server components, the rendering, when you render it on the client side, it's going to remove all this library context. What it's just going to do is it's going to generate this HTML and use the HTML and then send that HTML to the client side. That's basically it. So you have the HTML that's created for you, and this HTML, you need not worry about the dependencies. So it is a converted thing that will go and end up there. By this way, you're eliminating the bundle size to a maximum extent, and you're talking to the database much faster. You're beefing up your server infrastructure because that is required. When you have more connection, your server is going to have more load, so you're going to beef up your server-side infrastructure. But this paves the way for low-end devices or devices with much lesser network connectivity or something like that. A device from a developing country point of view, if a device isn't there, then it gives that flexibility for you to take that load on your device, on your servers, and just push the content to them, and then they can take it. But this also means like if a user has an intermittent or flaky network connection, it is impossible or it will be difficult for us to handle that because server side happens everything on server side. You're just streaming the HTML into the end user. So a good network connectivity is required. You can talk in both direction. It might be required, it might not be required because I'm talking about HTML. I can stream those contents here and there. Uh, but it's a pros and cons that you can have with it. So it is sometimes can be seen as a pro because I just compile everything and just send streamable HTML to the end user, which is faster. Or sometimes your HTML is much bigger, you want to stream in multiple times, and it makes things more complicated. So it's always a trade-off that you have to think about in terms of network. But on the other hand, you have the bundling, smaller bundle size of JavaScript, which is a huge, huge advantage that you can take it out of server components. So that's basically it. And also you have to be aware like you cannot do user state migration or new use state and no user events. That is basically your server components will not have any interactivity attached to it. So that's basically it. If you have any questions, feel free to reach out to me at this handle. And thanks a lot for listening into my presentation. Have a good day.